All right, welcome back. Exercise 9-8. All right, so if you watch the lecture, you would realize very quickly this is quite hard. If I remember correctly from last year, completing the square was, I think, the hardest section for everybody. And it is for most people. It's very, very hard. So let's take a look. So the first problem says, of course, what's an example of completing the square and how is that useful? Okay, so the book gives out an example on finding the dimensions of a yard. Does that make sense? Some kind of dimensional analysis. Another thing that you could put here is, of course, like an in-class example is, of course, when whatever quadratic you're solving is not factoring easily. So if it doesn't factor very easily, that means that you could try to complete the square next, and that would help you figure out the answer a little faster. And so this method is super complicated, very hard, but very useful. You'll need this in Algebra 2, you'll need this in Pre-Cal, you'll see this in Calculus down the way. So this gets referenced a lot. Okay, let's jump straight in. So let's see, number 2, complete the square to form the perfect square trinomial and then factor it. Okay, so let's just go really slowly. So they say, complete the square to form the perfect square trinomial. So generally speaking, when I do these problems, you can think of this in two ways. Let me kind of write this large. So x squared plus 14x plus, and I put a box here for square. And but you don't have to actually. It's up to you if you like that or not. So when we complete the square, what we're doing is we're going to add something to make this into a perfect square trinomial. So let's just think about what would cause a perfect square trinomial. So we know that when we have perfect square trinomials, we always look to the central term, and we know the central term was doubled, right? So that means we had some 7x plus some 7x. That was the two central terms that were, when you distributed out the answer, you're going to get a 7x and a 7x, which is going to come to 14x as your middle term. So now, if we know that it was a 7x and a 7x, we can notice that these are the two terms we're going to multiply by each other to get this perfect square trinomial. So I'll show you what I mean by that. I know this is a little confusing, but just stick with me. So we know that it was a 7 and a 7, right? Now we need to multiply these two things by each other. That would give us 49. So let's write that down. That's what we're going to add to both sides of the equation to make the perfect square trinomial. Cool. And now they ask us to factor it. So to factor this, let's put our little parentheses down. X plus 7. Notice that 7's coming back. And x plus 7. Okay, so watch this play out, and all this will make sense, hopefully. X times x is what? X squared. And x times 7 is, here we go, here are the middle terms I was just talking about. 7x on the inside plus 7x. And finally the last, 7 times 7 is 49. So you'll see that does give us these first two terms, the x squared term and the 14x term. And we added the 49 ourselves. So this just confirms that we are correct. I just wanted to show it nice and clearly. So now once we factor it, that's it. You could write this similarly like this. You could say x plus 7 squared as well. And that's where that perfect square trinomial comes into play. Remember you guys learning this with me just a few weeks ago. So that would be 7 plus x, the quantity 7 plus x squared. So there's our first one. In the second one, I'll give you the cheat sheet that everyone actually uses. That's just kind of the theory. So the cheat kind of, I don't know, not cheat, but the quick way to do it is to just take the middle term. So take whatever the b term is, right, b, and divide it by 2, right, which is what we just did, and then square that. Cool? So that's the easy way to figure this out, right? So we're just going to apply this equation now to 2b. So 2b. So what is our middle term? It's a negative 4. So we go like this. We say negative 4 divided by 2 squared. So what is negative 4 divided by 2 squared? Well, that would be negative 2. Negative 2 squared is just 4. So yeah, we're just adding 4 here. Cool. Let me actually write this all out so we can factor it next. So x squared minus 4x plus 4. So we just slap that term in there. Now we factor it. So, of course, this is going to be what? X minus 2 and x minus 2, which gives us the quantity x minus 2 squared. There's our perfect square. Now, either method's totally fine. Feel free to practice both. Obviously, this is the way most people use, right? It's easily rememberable. All right, let's do it again. Oh, sorry. X squared minus 3x. Okay, so take our central term, divide it by 2. So this is something you can do in your head. So negative 3 divided by 2, and then square that. So I will write this down. So I'm going to say plus, I'm going to say negative 3 divided by 2 squared. Now, a whole nother method, it's really all the same thing, but a whole nother method is to just actually write the whole thing out, just like this. And I'll show you why just now. So negative 3 divided by 2 squared, which is what? It's going to be 9/4. But that actually doesn't matter. That doesn't really help us. What we want is inside this parentheses. So let's factor it. X and x. And guess what goes in as the other term here? It's going to be minus 3 halves. X minus 3 halves. So notice that this term that we created just a second ago is actually the one that goes into the parentheses. It's actually our binomial answer, right? And then ultimately this, right? So that's equivalent to x minus 3 halves squared. Cool. So this is like the official way to solve this. And they're really not too hard. You can, of course, go back and practice the other ones the exact same way. Notice and look for all those patterns to emerge. Okay. Number 3. Okay, solve quadratics for x by completing the square. Okay, it gets a little bit harder now. So before, all they were doing is asking you, what do we add to both sides of the equation to create a perfect square? So in this one, of course, we divided 14 by 2. We got 7. 7 squared, 49. So we would actually need to add 49 to both sides of the equation. So let's come down here and let's actually do the real problem so we don't waste any time. So let me write this all out. X squared plus 6. I'm going to move the 5 over. Plus 5 equals 0. All right, that should be what you got. Now, notice that we can't factor this. This is no good, right? Or can we factor that? Sometimes they make mistakes. Is that factorable? If it is, we should just factor it, right? There's no need to complete the square. So if they did that to us, we might be able to slide by just factoring it. So what if we did 5 and 1? What if we did x plus 5 and x plus 1 equals 0? Does that work out? X squared, 5x, 6x. Yeah, this works. So our answers would be negative 5 and negative 1. Okay, so they made a mistake because they gave us one that you could factor. So that's the answer, but let's actually do it the way they want us to do it. All right, great. So the way they want you to do this is to return the 5 to the other side where it was. Cool. We're going to add this mysterious square, if you will, and we're going to say equals negative 5. Okay, now, so what do we do to figure out this block? That's our very first step. So you look to the middle term, and this should say 6x. My apologies. Good, we look to the middle term, 6. We divide that by 2 and square it. And like I said, I'll just write it exactly like that. So 6 halves is just 3. So let's say 3 squared. Cool. Now, if we add let's see, this is actually what we're doing in algebra. So we always have this fulcrum and our balance, right? So if we're adding 9 to the left-hand side of the equation, what must we add to the right-hand side of the equation to keep it from just being completely imbalanced? Well, we'd have to add 9 to the right-hand side too. Right, that just makes sense. So we need to do the same thing, but in algebraic terms to the right-hand side. So we need to say plus 9. You'll see why I wrote it in 2 different ways in just a second. So plus 9, and make sure the signs are consistent. Right, if you add 9 on one side and subtract 9 on the other, that wouldn't be equivalent. So let's play this out. So this becomes a x plus 3 squared, right, equals, and then what's negative 5 plus 9? That's going to give us just a positive 4. All right, then we take a square root of both sides, right? We get x plus 3 equals plus or minus 2. If you recall that from our perfect squares section just a few back. Cool, now this is going to give us two answers here. We need to be extra careful. So the first answer is going to look like this. It's going to be x plus 3 equals positive 2. So minus 3, minus 3. So x is going to be negative 1. And I'm going to have to write even smaller. X plus 3 equals a negative 2. Minus 3, minus 3. X will be negative 5. Okay, that should be consistent with what we got when we factored it. And I think it is. That is it. That was totally what we had. So, very long way to go about this, and that's why people tend to be frustrated with this method. But it is actually quite straightforward. Hopefully I showed you the quick ways to do this, the fast ways to do it. So our two answers here, if you can't see clearly, are x equals negative 1 and x equals negative 5. I'll try to write smaller next time. Okay, excellent. So that was just one of them. Let's try the next. Let me get some space. Okay, so 3b. So we have x squared plus 2x plus, so just half the middle term, half of 2 is 1, 1 squared is just 1, equals 21 plus 1. Okay, so we added 1 and we added 1. So now we factor this, x plus 1 and x plus 1 equals 22. X plus 1 squared equals 22. Square root of both sides. We get x plus 1 equals root 22. And that's plus or minus. So our answer is going to be x equals negative 1 plus or minus root 22. Now, you can put this in a calculator to figure this one out. This is a really good example of how these really work out. So the only time when it's really functional or practical to solve these problems is when you get some crazy square rooted number, which we have here. So this is actually two answers. This is x equals negative 1 plus root 22, and x equals negative 1 minus root 22. All right, that's it. That's as far as I would go. You can, of course, put it in a calculator if you wish and get the approximate answer. All right, I went a little fast. If it's fast for you, you can always just pause and go slow. X squared plus 16x. What's half of 16? 8. So I'll just write 8 squared equals 92 plus 64. That's what 8 squared is. We're going to add it to both sides. All right, so we already know what the perfect square is going to be. Right, this number gives it away. X plus 8 squared equals, what's 92 and 64? Let's double check this. Oopsie daisies. 64, this gives us 6, 15, 156. Okay, 156, good, square root. Square root, that is not a perfect square for sure. So we get x plus 8 equals plus or minus root 156. And just like last time, we just move the 8 over and we say negative 8 plus or minus root 156. And that's two answers. All right, excellent. All right, last one. Hopefully you're still hanging in there. 3D, negative x squared plus 8x. I'm going to move this guy over to the other side. So just hold off on that for just 1 minute. Let me actually do it now. 6. So now what is half of 8? 4. 4 squared. Now we have this negative out in front of x. This is kind of going to mess us up. And we should think about this. So now, what do we do with that negative? Is that going to alter our answer? I would say definitely. Right? So to be able to do this, we need to have the coefficient of the a term, or the first term, to be 1 and not -1. So what is something we could possibly do to alter this? Well, here, let's actually walk this step back. Right. We could actually run a negative through the problem. We could multiply everything by -1. So then we would get x squared minus 8x equals -6. Okay, so it's not going to mess things up too much for us. What is half of -8? Well, let's see. It's going to be -4 squared. It does change things a little bit. And then if we add a -4 squared to this side, we have to add it to the other. What is -4 squared? It's kind of a trick question. So that is going to be positive 16. -4 times -4 is positive. Good, and remember this kind of gives away the perfect square here. So we get x minus 4 squared equals -6 plus 16, which is just 10. Square root, x minus 4 equals plus or minus 10. And then just like last time, I'm running out of space again. We move the 4 over, plus or minus root 10. And of course, you can put that in a calculator and get a nice approximate answer for that. All right, that's it. That's all there is to it. Double check your answers. Write me if there are any inconsistencies, if you didn't understand something. Let's see. So this one is interesting. Let me just quickly recap this before we go. So notice that the negative is out front. That's kind of the trickiest form of this question. You can't solve this without making everything. You have to multiply the whole equation by -1 because that lead term needs to be positive. And once you do that, you can solve it just like normal. So hopefully that makes that one easier. Okay, good luck. I'll be seeing you guys soon, hopefully.